This cable is smooth. This is a cabin. The whole cabin is revolving in a big radius. Big radius means everybody can be considered at r distance, whether m1, m2 or pulley, from the center of the circular motion. Omega is the angular speed of the cabin. Find acceleration as seen by the cabin. It's a case of non-inertial observer. Find the tension in the string. Now your observer is inside the cabin here. Right, so your observer is also accelerating, and therefore pseudo forces would be required. On m1, the pseudo force would be m1 v square by r, but omega is mentioned. So in place of mv square by r, use the formula mr omega square. That is m1 r omega square. That's the pseudo force, which is also called centrifugal force. This fellow m2 r omega square, tension T, same string, tension would be the same. Pulley is light, frictionless, the usual things are there. Now we are talking about horizontal plane, so should we talk about gravity? Now cable is smooth, so we don't need friction also, so we don't need normal reaction. So we don't need to worry about the vertical direction where mg will act, where normal reaction will act, right? So let's not show those. Now, why would there be motion at all? That is m1 going here or m1 going up, whatever it is. That is because m1 r omega square may be larger than t, or m2 r omega square may be larger than t, right? That's why. So in this direction, when we say net force m1 r omega square minus t, and that would be equal to m1 times a. Then if this fellow goes like this fellow must go like this. That means T minus m2 r omega square is equal to m2 a. As I said, radius would be the same for this also, as radius is large, so small distances would be ignored in comparison to the large distance. You have two equations, you have two unknowns, you can find them. Yes, that is okay. I think m1 minus m2, it should be m1 minus m2. Now if you have any questions regarding this discussion, then let me know. I don't see any questions. I was noticing something else for T. That's why I worked it out here. Just see if you're getting T equal to this. So these two m1 r omega square and m2 r omega square are shown because this observer is considered. If you consider Newton somewhere here, then they will become 0. They won't be there. And note one more thing. When we considered this observer, did we ever mention centripetal force? The answer is no. When this observer is considered, there should be no mention of centripetal force. Again, we have a big cabin. In that big cabin, there is a table, and that big cabin is revolving in circular path of radius capital R. In that table, there is a groove, and it is smooth groove. It's a smooth groove whose length is L, and L is much small in comparison to the radius. That means from O to A if you consider, or from O to B if you consider, we don't have to worry about small distances in comparison to the big distance R. There is a particle at A at t equal to 0 time. So in how much time will that particle reach B? In how much time will that particle reach B? That's the question. I hope the question is clear. Here there is no mention that you have to consider non-inertial observer or inertial observer. If you like, place your observer inside the cabin, or if you like, place your observer outside the cabin. We will place our observer inside the cabin. So my first question, just select yes, no. Yes, no can be selected from here. The question is, do we need to consider centrifugal force? And the answer is yes. Why will that particle move at all? This person will say that this particle is experiencing centrifugal force. Centrifugal force is away from the center. That is a centrifugal force. Table is smooth. I mean, that hole is smooth. Hole is also smooth. Centrifugal force is in this direction. The particle is inside the hole, inside the slit. So particle cannot move here. Particle will have no choice but to move here only. So why will the particle move? This person will say there is a centrifugal force acting and that centrifugal force will have a component in this direction, it will have a component in this direction, two components. 1, 2. It is due to this component that the particle will move. Due to this component, particle will hit the boundary, so this component will be balanced by the normal reaction of the walls of the slit, this component. This component will be responsible to move the particle from A to B. That's the physics. So how much is the centrifugal force? If the mass, I think, okay, mass may get cancelled. Let's take it as m. So centrifugal force will be mr omega square. Cos component mr omega square cos theta. That's the net force. So that will provide the acceleration. Acceleration would be r omega square cos theta. This is constant acceleration. R constant, omega constant, theta constant. Constant acceleration, L length you have to travel, time can be obtained from this. So m will not come in the final answer. Why u is 0? Particle is kept at this point. That's why u is 0. S equal to ut plus half at square. The answer I have is 2l upon omega square r cos theta all inside the root. Any questions? Let me know. Imagine a hemispherical bowl having friction coefficient mu. Some block is kept at some angle theta. Ball is rotated with angular speed omega. We don't want this object to move. We want this to rotate. We don't want it to move up or down. We want it to rotate along with this. What should be omega minimum and what should be omega maximum, so that the block remains at the same angle theta? Remember that problem which we discussed, that angle of banking is there, and if you go too fast, what happens? if you go too fast, you climb up. And if you go too slow, then what happens? You skid down. That was for angle of banking. If you go too fast, radius should increase. And if you go too slow, you may slip. If omega is too fast, too much, if omega is too much, keep your observer here inside, so that centrifugal force will become more if omega is more. Centrifugal force is mr omega square. Centrifugal force is away. So due to that force, climbing up will take place. Too much omega, it will go up. Take some water in a cup and rotate it fast. See what happens. Water can possibly splash out if you rotate it too fast. So in a circular path, if you try to go too fast, you may fall on the side away from the center. You can fall on the side away from the center. For this, center is this. For this, center is this. Away from the center, it will climb up. If omega is too much, if omega is too small, imagine keeping a particle here, what will happen? Skidding? Yes, friction will try its best, but if friction can't stop it, there is no choice but to skid. Okay? So that's the physics, rest is mathematics. So if you like, place your observer inside. You can place your observer outside also, but I am placing my observer inside. So I will need to consider centrifugal force. For this object, circle is not having this center. This object is moving like this, round and round and round. So the circle is this. So what is the radius of that circle? This is r. Yes, this is r. That is given as r. So r cos theta, this is r sin theta. Therefore, the centrifugal force would be m times radius into omega square. Omega is same for everybody, that you must understand. When a ball rotates like Earth rotates, everybody takes 24 hours to complete. Everybody takes 24 hours to complete one full circle. So somebody who is at equator, big length, but same time 24 hours. Here 24 hours. What I am trying to say is omega and t don't change. Omega does not change for different particles, because omega is about angle, and whether you consider somebody at equator or if you consider somebody somewhere closer to the pole, yes, they are traveling different distances, but are they traveling different angles? This is a circle, and so is this. Circle, circle, they are all 360-degree angles. Omega is theta upon time. So angle is same for everybody. So when some object, solid object, rotates with some angular speed omega, then everybody inside it rotates at same omega. Inside it also, not only on the surface, but inside it also. So some water particles inside 100 feet or 150 feet or even more than that, some other particles, they will all have same omega. That means whether you consider this particle this round and round, this particle this round and round, this particle this round and round, for everybody omega is same. So this omega is for the whole object, you can say. It is for every particle of that object. Speed may change. Speed may change. Somebody who has to travel more distance in the same time must travel faster. Somebody has to travel more distance in the same time must travel faster. Somebody who has to travel less distance in the same time must travel slower. So linear speed may be different, but angular speed is same for everybody. So many times it is convenient to deal in angular speed. In rotation topic you will see angular speed we use quite a lot. It's very convenient. Solid object performing rotational motion, everybody is having omega, every particle. Very convenient. Centrifugal force is mr sine theta omega square, and that is acting in this direction. And friction coefficient is mu. Now friction will try to help, but firstly normal reaction also. Again mass, we hope mass cancels out. So normal reaction, then gravitational, friction. When we are discussing omega max case, there is a tendency to go up. Friction will help in not letting that happen. That means friction should be acting in this direction, in this case of omega max. So let me write here omega max case, because direction of friction can change. Direction of friction can change otherwise. Now friction will do its best, means it will become limiting. It is static friction. It is static friction, no slipping taking place. Yes, if static friction gives up, then slipping will take place and it will slip up. So maximum is mu n, static friction. Now there are four forces and we just need to balance them. This observer will say, well, small m is at rest, so everybody should get cancelled. For that observer, small m is at rest, isn't it? We all are moving too fast, but what do we find? We find houses are at rest, people are at rest as long as they are standing, even though everybody is moving at a phenomenal speed. So this observer and this m both would be rotating actually, but one says that other is not accelerating. Rest. So it is our choice which two perpendicular directions we go for. Let's go for the usual x this and y that. So that means mr sine theta omega square is on the right side. Left side would be normal reaction. This angle would be theta. N cos theta is here. N sin theta will be here. N sin theta. And for friction, this is theta. So this will be how much? Theta only? How much is this angle? Theta or 90 minus theta? (90 minus theta). Yes, it should be 90 minus theta. This is 90 minus theta, right. So cos theta will come then. Un cos theta. Un cos theta here. These two will jointly balance this fellow. Then vertical n cos theta will balance un sin theta plus mg. That's it, two equations. You don't want normal reaction and you want omega. Theta is given. I don't think that should be a problem. Two equations, get rid of n and find out omega. Can you do that? Answer is big, so I'm writing it on the board. Now, before I proceed to discuss omega minimum case, if you have any questions concerning this discussion, then let me know. Looks like no problem with omega max. Let's go to omega min. If it is too slow, let me copy this board to the next board. Equations should change. Now, the very first thing is to look at the direction of friction. This particle is too slow, so obviously gravity will make it fall, flight. Friction will help to its best of its abilities. So it will reach limiting value and then sliding will take place. Friction will help means it will act in opposite direction. That's the key point. It will reach its limiting value. Then centrifugal force, observer is same, centrifugal force will be the same, but omega will be omega min square, or breakup of normal reaction will be the same, r sin theta is same, mg is same, only friction. Now, limiting case we are discussing, right? Just it's possible if omega falls below omega minimum, sliding towards the downward side will take place. If omega falls below omega min is the limiting case. Right side force mr sin theta omega square. Friction will also be right side, component I mean. Now which component on the right side? This angle is theta, so 90 minus theta. How much will be this angle? Theta or 90 minus theta? Theta? 90 minus theta. Let me check. This will be theta 90 minus. Can you check again? That means mu n cos theta, right? That's right side. Left side only normal reaction, and this angle is 90 minus theta, sin theta. And sin theta will have to balance these two. Then vertical direction friction, mu n sin theta, then normal reaction cos theta. These two will jointly be balanced by mg. You have two equations, get rid of n and find out omega. This omega is omega min. This omega is omega min. And I am writing the answer on the board. See if you are getting this. Okay. Now, any questions regarding this discussion of omega min? Let me know. Alright, so you have cushion sort of a thing. There is a cushion. Just like that discussion, when you take a turn, if you go too fast, if you go too slow, but there is a cushion in between. How is this cushioning actually work? This cushioning works because of static friction. If static friction were not self-adjusting, then this cushioning will not take place. Then there would be rigidity. This is what it should be, that's it. End of the story. But that's not how it is. There's a cushioning effect, and that is possible due to the behavior of the static frictional force. You must have heard about that what sounds like a dangerous game, a motorcyclist trying to cover a vertical circle. You have bucket of water and you tie it to some rope and you rotate it in a vertical circle. Water does not fall. Water does not fall if you are having enough speed. So high speed is not always dangerous. High speed makes water not fall, and that motorcyclist who is trying to play that stunt, in fact, slow speed can be a killer for him. Slow speed can be dangerous for him. Why is slow speed dangerous for such activity? Somebody trying to do round and round. Imagine the person is at the worst point, the topmost point. This is, let's call it motorcycle. Now, earth will pull it down, so the person has to beat earth basically. And he beats earth by his speed. If you watch this from, let's say, earth's inertial frame, if you watch it from inertial frame, just think of the two situations. Somehow a bike manages to reach some height without anything. Some bike manages to reach this point with some surface in contact. In this case, well, there is no hope really. Earth will pull it down, it will bang into the ground. But in this case, there is somebody to fight mg. Inertial frame will say that because this bike is traveling at some speed and is moving in circular paths, centripetal force is required, and there are two forces acting at the topmost point, mg and the electromagnetic normal reaction. Jointly, they will provide centripetal force. In the worst case, that motorcycle is just losing contact and will become zero, but still that's the limiting, that's the borderline case. That case, still we can say that mg is providing centripetal force. This is what happens to satellites. Satellites that go around the earth, who provides them centripetal force? mg provides them the centripetal force. So motorcycle, in that case of normal reaction becoming just zero, that type of case it would become. mg is providing the centripetal force. The satellites which go around the earth, whether man-made or nature-made like moon, they all work like this. mg equal to mv square by r. So why doesn't moon fall? Why does this block fall and why doesn't moon fall? Why doesn't moon fall? Because the mg that is trying to make moon fall is actually made busy in providing the centripetal force. So mg is now busy in providing the centripetal force. So it does not cause moon to fall. Here in this case, mg is focusing on making this fellow hit the ground. Circular motion protects, speed protects. If in this case, if motorcyclist is going with too small speed, well then mg is too much, let's say, and complete mg is not consumed in providing mv square by r. Then you can imagine what will happen. Motorcycle won't be able to complete the circle. So high speed is a requirement for this type of stunt. If you want to make water bucket filled with water successfully complete a vertical circle without water falling, then there is a requirement for speed. So what's the answer to this? When you tilt, when you bend, mg does not change its direction. Mg is going to be always downwards for you, towards the center of the earth, no matter what posture you adopt. I think upthrust makes more sense, because think about airplane also. It should be the thrust. So imagine wings moving downward. Of course, instead of downward, you will have to think at some angle at the time of turning. But just think, for the sake of simplicity, wings going downwards. When wings go downwards, what happens? Thrust is upwards, isn't it? Whenever you are inside the water and you want to come up, it's very easy to do. Just thrust water with your hands downwards and you come up. So similar argument works for any other fluid like air. Air is fluid. So thrusting it downwards will give upward thrust. Now instead of thrusting downwards, imagine thrusting at some angle. The component of that thrust should be able to provide the centripetal force. It's like banking type of case. Bird at this angle and bird thrusting in this direction. The upthrust is like this, like normal reaction in banking case. It's just like normal reaction in banking case. Component of that is towards the center. Well, earlier I was thinking of not giving assignment, but now I think I should give this question as assignment. So let me understand what you are thinking. So provide your explanation in the assignment. This is the assignment question. We stop at this point.